Okay, this is another problem similar to the yo-yo. It's the one right underneath it in the packet. What is the period of a 25 kilogram wrecking ball swinging in a horizontal circle if the distance from the center of the wrecking ball to the top of the chain is 4.8 meters and the chain is 5.8 meters long? So what we're looking at, you've got wrecking ball swinging around in a circle. It tells us that the length of the chain is 5.8 meters long, so this is 5.8 meters. And it tells us that the distance from the top of the chain to the center of the ball, so this distance right here, is 4.8 meters. So we're given the length of the string and we're essentially given the y component, or the y side of the triangle. So if I list my givens, we know those two things. So we know that the length is equal to 5.8 meters. And what I'm going to call this 4.8 meters is the height. So height equals 4.8 meters. And it tells us that the mass is equal to 25 kilograms. What are we looking for? Period. So we're looking for the time it takes to go around in a circle once. So trig. Here's our triangle. Oops, get rid of this. Our radius is here. This is the height, and this is the length. Giving us length and height, you can just use Pythagorean theorem to figure out what the radius is. So x squared plus y squared equals r squared. In this case, L squared equals h squared plus r squared. So L squared minus h squared, taking the square root of that will give us the radius. So simple Pythagorean theorem. And this comes out to 2.88, keeps on going, meters for the radius. And that's something that you want to store in your calculator, well, probably as r. So now we know all three sides of the triangle. Next thing we're going to want to do is figure out the angle. Because we know all three sides, you can use any trig function you would like. So either sine, cosine, or tangent. I'm just going to use tangent. So tan theta is equal to opposite over adjacent, so the height over the radius, which means that theta equals the inverse tan of height over radius. So this equals inverse tan of my given height, 4.8 meters, divided by my radius, unrounded, 2.8 keeps on going, meters. So theta is equal to 58.99 keeps on going degrees. And I usually store theta, you can store it as anything you want. I tend to do t, since theta begins with a t. So there's my theta. This problem is very similar to the yo-yo. So now we're going to draw a force diagram. You have your wrecking ball. It's being pulled up by the chain, so that would be a tension force, moving around in a circle. And the circle is horizontal, where center is over here. So breaking apart that tension force into Ftx and Fty. And we're going to follow the same steps that we did in the yo-yo problem. We know that Fty has to equal Fg because it's not accelerating in that direction. So Ft sine theta equals mg. Ft equals mg over sine theta. And then in the x direction, we know that Ftx is the only force acting in the direction of the center of the circle. So Ftx is equal to centripetal force. Ft cosine theta equals mv squared over r. So Ft equals mv squared over r cosine theta. Setting this equal to this, let's figure out what our speed is, since that's the only unknown. So mg over sine theta equals mv squared over r cosine theta. You're going to notice that again the mass cancels out, it doesn't matter. GR cosine theta equals V squared sine theta. GR cosine theta over sine theta equals V squared. Why am I solving for speed if it's asking for period? Because the only way to find period is by using the radius and the speed, so we need to find speed in order to get period. The only unknown in this equation is speed, so I just have to now put the numbers in. So G, 9.8 meters per second squared, times the radius. If you stored that number as R, you were smart, so 2.88 keeps on going, meters. Cosine, if you stored the angle as T, you were again smart, so this is 58.9, keeps on going, degrees, divided by the sine of 58.9 keeps on going, degrees. And that equals my speed squared. Putting all of this into the calculator, you're going to get 16.98, keeps on going, meters squared per second squared, for the speed squared. Taking the square root of that, we get a speed equal to 4.12 meters per second. But this is not my final answer. We're looking for period. The only equation with period is speed equals 2 pi times the radius, so the distance around a circle, divided by the period. So period equals 2 pi times the radius divided by the speed. Period equals 2 pi. Again, if you stored the radius, you're in a good place. So 2 pi times 2.88 keeps on going, meters, divided by the speed you just solved for, unrounded, 4.12 keeps on going, meters per second. We get 4.39 keeps on going, seconds. So the period with 2 sig figs is approximately equal to 4.4 seconds. So 4.4 seconds for a wrecking ball with a 5.6 meter long chain is pretty reasonable. It's going to take a while for a 25 kilogram wrecking ball to make that large of a circle. So our answer makes sense. Again, the steps are pretty much the same as the yo-yo. If you watched the entire yo-yo video, you would have seen the 2 other ways to solve. It's okay to use either of those 2 equations. So again, any of the 3 ways to solve this is fine. You'll find that I tend to just derive it every time. And then once we found speed, we had to use that to find period because this is the only equation that has period in it. So period depends on your speed and your radius. You need both of those in order to find the period.